Good evening. Welcome to this evening's webinar, Investigations in Year 10 Mathematics. You are in for a treat here. My name is Brian Lannan and I will be your host this evening. And our presenters, both from Queensland, we will be hearing from Melissa Hourigan, who is a T-Cubed instructor, Hi Mel, and an experienced webinar presenter and basically developer and sharer of clever classroom ideas. Also very experienced, Rodney Anderson, also T-Cubed instructor and a regular webinar presenter, and on the committee for AAMT and QAMT. Rod, are you still president of QAMT?
No, I've just stepped back this year, so I'm vice president, still on the executive committee, so still heavily involved with QAMT.
Because I think your conference is coming up fairly soon, is it not?
That's correct. It's in Toowoomba this year, in June. Thank you for that plug there, Brian.
Yeah, I'd love to get up there, but Toowoomba's going to be cool though, isn't it? Up on the tablelands there.
Yeah, it can get a bit cool at times, but it's a lovely temperature that time of the year in June.
Oh, okay. So so people listening should make the effort to get along there. I'm going to hand over. We've had an interesting practice session where Melissa and Rodney have been showing me some of the great activities they've got for Year 10, and a lot of them particularly with data collection, which I think is very, very engaging material. So, Melissa
has... ready and raring to go.
Ready and raring to go. I will hand that over to you now. And I know you've been setting up some equipment for live experiments.
I have been. So I will just get onto what I want to look at. So what we're looking at tonight, Rodney and I, is investigations in Year 10 Maths. And hopefully you'll get a few ideas of little activities that you can run with your students, rather than just always providing data to them, actually getting the students to collect the data. And they take more ownership of the data and can interact, I guess understand it a little bit better if they've collected it. So what I'm going to be looking at tonight is two activities that are based around data analysis and in particular with a focus on linear functions. So my two activities, the first one is Fahrenheit versus Celsius and the second one is forensic maths. It's called Tracks of a Killer. From there, Rodney's going to be looking at some data collection as well, and periodic motion, another Year 10 topic, and seeing how we go, we're also going to look at area of a kite activity, or Rodney's going to look at area of a kite activity. So fingers crossed we can get through the activities and you can get some things that you can run in your classroom tomorrow. So my two activities, as I said, I'm looking at data analysis, so gathering the data and focusing on linear functions. So where does that fall in the Australian curriculum? First one is using scatter plots to investigate and comment on relationships between two numerical variables. So I'm looking in the Australian curriculum P to 10 or K to 10 here. And the second part, solve problems involving linear equations, including those derived from formulas. But I'm looking more at the problem-solving ideas, so how can we use something like this and apply it down the track. So those are the two areas I'm looking at, and of course the whole idea behind the webinar of using the calculators and having students use the calculators effectively. So let's get started on the first one. So Fahrenheit versus Celsius, I got this idea from the TI website. So that the TI website, the American website, has a lot of activities. The Australian website does too. The Australian website has them based on the Australian curriculum. You can get a lot of activities from the American TI website. Obviously, you need to be aware that everything on there is based in your American units. So anything that you get dealing with temperature, they will generally be using Fahrenheit. So you give it to students, and often students will go, well, what are they talking about? So the idea behind this activity is to actually look at how you can convert between the two. And what is the relationship between them? The other reason I like this activity too is as much as we don't use Fahrenheit here in Australia, we watch a lot of television, or some people do, watch a lot of television from America. So when they talk about it's 100 degrees outside, what really is that in relation to what we're used to here? So the activity uses the TI-Nspires, either the CAS or the non-CAS, uses a lab cradle, which you connect to the back of it, and we need 2 temperature sensors to collect the data. Now, as well as that, for this activity, we need some cold water. Now, I've got in here cold water, beaker of cold water, beaker of hot water, and a beaker of tap water. I haven't got the cold water, the ice water, but I have got actually a cold ice pack from my freezer, and I have got some hot water. Well, it was hot about 10 minutes ago when I boiled the kettle, so it will have dropped down a little bit. So I don't have the beaker of just tap water at the moment, but we can still do the activity. All right, let's get started. First thing that we need to be able to do is connect our TI-Nspire to our lab cradle. So the calculators slide into it and lock into place. That's for the students. What I'm doing is I actually have my lab cradle connected to my computer. So if I go into my TI-Nspire software, I'm using the Navigator software because I use the Navigator system in my classroom. When I connect in, all I have to do is use the USB cable and connect my lab cradle into my computer with the USB, and it works just the same as the students connect in as well. So if I go into a new document, I won't save my unsaved document. I can choose Vernier Data Quest, and it's already there. When the students connect in their calculators, they should actually see that collection screen open up straight away. So if they don't, it could be there's a slight connection problem, maybe the lab cradle's lower battery, it's not getting enough connection, that sort of thing. A few things you can look at there. So the next thing we're going to do is we need to actually connect our 2 temperature sensors. So I'm going to flick back into my software, and I'm going to go into a document that I set up a little bit earlier. You can see here that I've actually got, where I had it set up earlier, it registered 2 of the sensors. So I'll collect one sensor, and we go fingers crossed this is going to start working. And so that's the first sensor has started to pick up the temperature. Second sensor, and fingers crossed that one's going to start working. So as soon as you connect in the sensor, it will start reading the temperature. Now these are just the metal sensors. They just connect into the side of the lab cradle, very easy to use. So at the moment, they're just registering the temperature, air temperature here in my study. Not too bad at the moment in here, 22.4 degrees. It was cold earlier in Brisbane with the rain we've got at the moment, so quite happy I'm inside, not outside. All right, back onto our activity. So the PowerPoint, which you are able to access, it will be sent to you after the session, then goes through and has in it the steps to set up for data collection. Okay, so we'll go through those very quickly. So easiest thing is you go to menu. We're doing an experiment, so number 1, and I need to set up my sensors. Now, because I've already set them up, we can see one was in Celsius and one was in Fahrenheit, but very quickly, you can see here I've got 2 items or 2 sensors. They're stainless steel temperature sensors. We can change Celsius, Fahrenheit, or Kelvin if you want to, so I'll leave that as Celsius. I've chosen 2 decimal points for precision. You can drop it back to 1. It says that it's going to put the data in run1.temperature. Good to note if you're doing the experiments a couple of times over. And then I'll click OK, and I go through and do the same thing very quickly with my second sensor. This time, excuse me, I've set it at Fahrenheit. So now I've got my sensors gathering data, sensor 1, Celsius, sensor 2, Fahrenheit. Now the next thing I've got to do is set up how I want to collect the data. So again, back into menu, experiment. This time I'm going to collection mode, and I'm doing events with entry. So you'll actually see later in this webinar that what Rodney's doing is his collection mode is time-based. Okay, mine's events with entry, so rather than collecting data across a period of time. I'm going to discard data that I had previously. It asks you to name what it is you're doing, so I'll call this Celsius versus Fahrenheit, and I'll click OK. So it's given it an event name down here. I am now ready to go. As with any data collection, green box up here, we press that. Students can press that on their calculators using their cursor, and we go into the data collection mode. Now, you'll see on the screen here that we've actually got 2 points. That's the data at the moment. So the first thing is you get a student to put both temperature probes in their hand, close their hand around the two of them together, and you can see that the temperature is going up. So we've got the temperature, exact readings down the left-hand side here. Now what they need to do is hold on to that and wait until that starts to settle. Because we're limited on time, I will just collect my data. So I press the camera, and that's going to be data point number 1. I've taken the probes out of my hands now, and I've got my nice little freezer pack. And we can see now that the temperature is dropping. I'll wait for it to drop down just a little bit further. So this is where you're putting the 2 temperature probes into your ice water. Okay, when it again settles, seems to have hit its temperature, you will again press the camera, and that's data point number 2, and press OK. And finally, we'll take my hot water, which is now lukewarm, and we can see the temperature increasing there, just so I can get a bit of data, bit spread out. I'll let it go up a little bit. And again, we press our camera, and that's data point number 3. With the experiment that I've got instruction-wise on the PowerPoint, it says to then also do the tap water, so that you've just got a 4th point there. I could do a 4th point now. I'm back at air temperature again. I'll call that point 4. I'm going to stop there. So I press the stop, and I've now got my data available to me. What I'm then going to do, you can choose to be in the table view when you're gathering data, and it gives you, these are your points, they're your temperatures. You can choose to be in the graph mode that I was in. You can choose if you want to be back here on the main screen. What I want to do now is analyze that data and look for the relationship. So I'm going to insert a data and statistics page. So you can see I chose 4 points, or gathered 4 points. Down the bottom, I'm going to put run 1 temperature, which is my Celsius. And on the vertical axis, I'm going to put my run 1 temperature 2, which was Fahrenheit. So that's the data that I collected. When you're doing this in class, you get the students get to that point there, and you ask them the question. And perhaps, Brian, you might like to do one of those polls now. Is there a relationship, and if so, what is the relationship that seems to occur between our 2 sets of temperatures? So you can do this as a quick poll with your students as well in class when you're using Navigator. I'm not actually running the full Navigator at the moment, but I can do a start poll here and actually ask the question, is there a relationship? And they've got to answer. What type of relationship? How would you describe it? So from there, You are then able to analyse your data. So you can add a movable line, and the students are able to do that. I just went through menu, analyse, and chose number 2, add movable line. And if they grab the ends of it, they can adjust it slightly. I'll move this top bit down a bit. If they grab the middle where they get crosshairs, they actually move the line fully up and down at that particular gradient. So the ends are how you adjust your gradient, and the centre is how you adjust your line. So we could say there that we've got a bit of a relationship. Not the best. I think there's 1 point out down here. Okay, the other thing that you can do then is run a regression. So again, if I go into menu, analyse, this time look at regression, I think it looks linear. So if I run a linear regression, okay, it's actually put this line up here. And it's given me my equation there, which where I put my movable line wasn't too bad. I can now go in and actually move my movable line to match over the top, and we get our relationship there. Now, what we are actually able to access as well, and you can work with different parts, is that I mentioned before on the TI website, the American one, is there's actually an activity called Fahrenheit and Celsius. And it actually goes through and introduces and gives the instructions for everything that I've just done. Now the nice part with the activities, whether it's on the Australian website or whether it's on the American website, is that there are also worksheets that go with it. And the even better part, there's teacher answer sheets to it. So when you download the files, you get a PDF of the student sheet, you get a Word document of the student sheet so you can make your own changes to it, and you get a PDF document of the teacher version, which has the answers in it, which is always really nice. Saves you having to think sometimes in class. So what I also have is a copy of that document. So it goes through and talks about what they're going to learn, what the focus is, how to set it up. It gives you ideas for how you could do the quick poll I mentioned before, a class capture, but as well as that, it links in to the actual document that you can send down to the students' calculators. So as they move through, there's some questions there. Nearly the entire world uses what temperature scale? The next one, the United States uses, and the students answer this, and you can collect it back. So it's a good way of gathering some formative data as well. Shows them and tells them in their instruction sheet what they need to do there. Then asks them the next question, what type of relationship exists between your Celsius and your Fahrenheit? Okay, so they should be coming up with linear. What does the slope of the Fahrenheit versus Celsius graph represent? Okay, what is it telling us? Now that's Fahrenheit versus Celsius. If I go back here, what I can do is switch this over and put run 1 temperature 2 down the bottom, and it's switched over straight away to make it run 1 temperature 1. And we can again talk about what the equation is. What does the gradient mean? What does the y-intercept tell us? That sort of thing. So that's one activity there. The second activity that I am looking at, I'll just move on, is called Tracks of a Killer. Now I've actually run this activity with a Year 5 Science Maths Academy class that we have at school, which is an enrichment program we run with our local feeder primary schools. It didn't quite work as well because Year 5 you are looking at 10-year-olds, so their link between like their stride and their height, or their shoe length and their height, isn't quite as good as your teenagers, your year 10s, year 11s, year 12s. But they got the idea behind it. And again, there are the entire worksheet. I like this one case file. We were doing forensic maths, so that's why I did it. It goes through with the worksheets. Sorry. Goes through with the worksheet some information, talks about what they need to do, again, takes them through the process. In terms of the activity, again, all of the information is contained on here, so remove your right shoe, turn it over. Talks about how to measure their stride length. They're taking 10 steps, measuring that distance, dividing by 10, so you get the average stride length. And that's a good point of discussion with students of why don't you just take one step and measure that, and how you'll have students that will try and take the biggest step they can possibly take. Shows them the diagram, so the person starting here, taking their 10 steps, and that's where you're measuring to. Now, in this particular case, in the file, they actually put the data into a data collection, just like I was using with the Fahrenheit versus Celsius. It's already set up for them, this evidence record, and you can have a paper copy of that the students fill out, or I've also done it, what I did do with the Year 5, was I had the table up on the board, and I had the students, after they'd measured their height, get the whiteboard marker, write their height up, write their shoe length up, and write their stride up, and that gives you a data set. The other way you can do this is to just put in a lists and spreadsheets page. Call it height, call it shoe length, call it stride, and fill out the information. Now with tracks of a killer, the activity, as you go through, it says select the graph view on the previous page, so they go back, and if there is data in here, they will see, in this case, height versus stride length. If you're just doing a normal list and spreadsheets, then you are going to insert a page that is a data and statistics, and down the bottom I'm going to put height. On my vertical axis I will put shoe length, and then you can talk about, is there a relationship here, and why might we have this group down here that seems to be way off. Again, we can talk about, well, if I put in my movable line, where am I going to have it? We call it a line of best fit. I need to probably have, I've got 6 points above, I've got 4 down there, whether I need to move it just a little bit more. Seems to be going through a couple more points if I do that. And I've fit the line, or after I've done that, I can then go through and do my regression, and it fits the best line there. So I then am able to move my line around, etc., and compare it, and again talk about what the gradient is meaning in this situation, what the y-intercept is meaning in this situation. I can add another
and whether or not
page.
we include those other points, I dare say.
Sorry?
And even whether or not to include those other points that...
Exactly. How far out are these? Why? What's the issue? What's happened when they've been collected? Then you can do the same thing again, this time for height versus stride length. And we seem to have a much better set of data here, definitely much more linear. So again, go through that same process, add the movable line, and run your regression again. So with tracks of a killer then, it continues on, because the whole idea is you are solving a crime. So it's set up that there's been a crime committed, there were some footprints left behind, so you're able to measure the length of the footprint, so the shoe length, you're able to measure the stride length, and so from that, you then have to decide, okay, what's the correlation? Now, using that equation and the shoe length that you've got, by substitution, what height is the culprit, and by using the stride length and substitution, what height again is the culprit? Do they come out similar? Okay, they should hopefully. Why won't they be exact? And then the final part is you actually have to answer some questions. So why should you use linear correlations based on the data? Do you think it's possible to answer this? And eventually they have to decide who the killer was. And so the students can actually answer all these questions on their calculator, and you can collect the data back. That's another reason why I really like the TI-Nspires and using the Navigator system is you actually get a bit of an insight to some of the thoughts the students are having, and it gives you a set of data, a set of formative results that you can discuss with the students. You can discuss with their parents and just use that to help us make sure students are on track to be successful. So those are the two activities that I was looking at there. Again, with the worksheet, it goes through. This is the teacher notes, and it gives you a sample set of data so you can go through, and the sample answers is what I was talking about before, okay, the answers that you want for it, and who should be the murderer at the end, etc., or who the person is best chosen at the end. So that's two examples of where you can use data collection and linear relationships, and talking about gradients and actually applying your linear functions to actual situations. So what do they mean other than just y equals mx plus c? So yes.
Terrific. Thanks,
that's
Melissa.
my part.
Yes. I'll, just as we're heading over to Rodney there, Melissa, both of those terrific applications. And the forensic approach, or the story shell behind it, is something that can, can often be terrific in capturing students' attention, getting them in.
Oh, absolutely. Yeah, that's why I like that one. And as I said, I ran it with the Science Maths Academy students for something different, but doing forensic maths as opposed to just let's do some everyday equations. And it does just add that interest point to the lesson.
Yeah, some teachers online may recall a TV show about 10 years ago called Numbers, and I know that there was a collaboration between Texas Instruments and America's NCTM in developing activities in support of that TV show, some of which are still available on the same website, I dare say, Melissa, where you were getting that activity.
Sorry, what was that question? I got slightly distracted there.
I see. I was just saying the activities from the Numbers, or supporting the Numbers TV show.
Yes, if you just if you Google Numbers, remembering that when that TV show, the name was spelled NUMB3RS. So if you Google Numbers and Texas Instruments, the activities are actually still available in a few different places on the web, so you can just search for those. I like watching the TV show, and I often put students through that process.
Terrific. Yeah, I remember at the time I even bought the set of DVDs to go with it. Just watching the TV show alone is good. Yeah.
Oh, yeah.
Melissa, just before I hand over to Rodney, who he's either still at school or he has a whiteboard in his house.
Wouldn't surprise me.
All math teachers have whiteboards in the house, doesn't it, Brian?
The lab cradle, Melissa, a question came in, do you need to have a lab cradle in order to use the temperature probe?
You do if you've got the ones that have got the, what's it called, the analog or the channel connection. However, there is what's called, I think it was called Easy Temp, which has a USB connection on it, which can go straight into the calculators. But obviously the problem with that is you can only have one of those connected at a time. So
yes. So we wouldn't be able to do your experiment with 2 temperature
Not with
probes?
2, because you can only put one of the easy temps into your calculator at any one time. So to do that particular activity, it does require the lab cradles, yes. And it can be run using the old TI-84s and the CBLs. Runs the same way. Obviously, you've got to set it up, but yeah. So I mean, if you've got the TI-84 calculators, or your students have got those, you can run it with the CBL. It's the same temperature probes that you're using, and still collecting data, and they just have to go through using the TI-84 process with regards to having the data and then drawing the graphs, etc.
Terrific. Thank you very much.
No problem.
And thanks for clarifying that. I will hand over to Rodney, who has a whiteboard in his home.
Yeah, it's all ready to go there. Well done, Mel. Thank you very much, everyone, for that. Good evening, everyone. So, as you see there, I've just got my school laptop, and I've got the CBR in the classroom, and the USB connected straight to the motion detector to the laptop, and then you'll see just a ball bought at a local shop with some tape and some string attached to it, and all you've got to do is plug straight into the computer, and you will actually do something like this. So with the actual CBR, there are no batteries in the CBR, so I'm just getting the USB port, plug it in, and you'll see straight away I'm about to collect data. So you'll see at the moment where we are at my office, or my wife's office in the house here, that the motion detector is picking up the back of the wall. So if I put my hand, you'll see it, I'm about 25 centimetres from the actual the motion detector. So all I'm going to do is actually get the pendulum going, and so we've got to look at the pendulum periodic equation, develop that, and then go do a fly a kite activity. So there's no lines there. I hope not to go fly a kite. So what I'm going to do here is actually have my pendulum going, and what I'm going to do is set up my actual data collection. So what I'm going to do is select the menu, set up my experiment like Melissa did with her temperature probes. I'm going to go into collection setup, and I'm just going to collect it for 3 seconds. Like before, I could have collected for 5 seconds, and I'm going to get my pendulum going. I would need another hand over here. And all I'm going to do now is move my cursor up to the play button and press play.
Oh, that's very cool.
What do you think, Brian? Okay, that data, should we proceed with that? Or?
Not bad, Rodney, not bad.
So you could do a bit better, but as you see there, you've got the actual displacement and velocity graph, and a good thing here with the year 10s or even 11 Maths B, 12 Maths B, you could say to students, where is at the greatest displacement, what its velocity, you can line up the 2 graphs, and you can talk a lot more about that, like the greatest velocity occurs when, and so forth, and look at that. But with this one here, I'm just looking at the displacement, so what I like doing sometimes is actually just clicking on here, the menu, on the graph, and show graph, and just show graph 1. So I've got the data.
So we don't even need calculus there, but you can talk a lot about the gradients, so can't we, at particular points?
Yes, definitely right, yeah. That's the point. That's we're talking about the maximum and minimum velocity and the greatest displacement and what occurs. And it's amazing if you give I teach a girls' school, also the girls, give the opportunity, and they come to the fore and they answer the questions and they really understand what's happening. And the lovely thing about we all use with the motion detector, the students love matching their displacement to a graph and the preset functions, but that's another webinar in itself, looking at matching graphs. So what I'm going to do here is maybe generate the equation for this particular curve. Now, we're talking year 9, possibly year 10 students, and we could see that the lowest point around 0.2 of a metre, 0.6 of a metre, so we've got the data. Also, as Mel showed you before, you've got the metre only, you've actually got the graph of the data, and you've actually got the data points. So all that data is stored in the calculator. So what I like doing is actually inserting, maybe if I want to check the data, another application you could do it, you could actually do this. You can insert this in spreadsheet, and what you could do, you can say to yourself, maybe I could copy this data. This is what you could do. You could say to yourself, time, the first column. You could actually call the second column position, or another variable name if you'd like. And in this particular cell here for the column, what I'm going to do is press the variable keypad, and you'll see within here I need to press equals. I need to click the variable keypad and say, can I grab the data? And then you'll see run one time. So I can click run one time, and there we have our data. Then what you could do, the same thing with position, press equals, I can refer to it. You don't really need to call it time position to show you another opportunity. What you're saying before, you can strike out data. You know, the data before Melissa was showing when the students, or if you look at the TI file, a couple of data points are a little bit out, you could strike them through, but you should really keep them all. And select...
I really like the idea of putting it into the lists there manually, because it makes the students interact with the data in the lists more than just using the magical wizards from the data app.
Yeah, so you get that there. Like, I really enjoy doing that, and you think, okay, maybe I didn't want the first two data points, then you can strike that or delete those two rows. Then here's your option. Do you insert a graphs application, or do you insert a data and statistics? And I always like what Melissa does as well, is insert a data and stats application. So you can do Control-I, you can use the insert with the software. So if I just go Control-I for insert, I want to do a data and statistics. You've got all the data, and what have we got? So we're going to have position versus time. So I'm going to have time on the independent axis and position on the dependent axis. And there's our data. So you've got your scatter plot. So, well, the audience, so if you're participating here, if you're listening through, how many points do you need to generate this equation, and which points should they be? There's a question I could ask the people who are listening here, so we can do that. But so what I like doing with the students is actually, we'll look at this here and you think, what type of curve could I fit? So what I like generally doing is looking at a maximum and then a minimum, or peak or trough. And you can see one point, maybe we could use that one. If you look across here, maybe this point could be a little bit out. Maybe I could say here, with this maximum, you could say the maximum time would be 0.65 and its displacement is 0.583, for example. Then you could come down to here. I know you could store the points, want the students to interact with it at the trough, 1.2 seconds, and the displacement is 0.21, say maybe 5 meters, for example. So I've got my 2 points. So then that's what you need to do. So if you've got your 2 points, what you can do is use the calculator facilities, and we can generate the equation. So what I'm going to do now is insert a calculator application. So we can say to students it is a sinusoidal graph or a cosine graph, so we can do that. But first of all, we need the parameters now, A, B, C, and D. So you've got your amplitude, the frequency, the phase shift, and you've got the vertical shift. So what I'm going to do is assign a value for A. So I'm going to use the keypad and go Control, assign a value. You can actually have assign a value. And what's the amplitude? Obviously it's going to be the Y maximum, take away the Y minimum, and divide by 2. So let's do that. So if I go Control, divide, I always like using the fraction template, making sure there's no errors with the calculations, what they're typing in. So you see with the maximum we had before, we had 0.583, and I want the audience to actually make sure I don't make a mistake. So it's quite easy to type in the wrong numbers, 0.215, and divide by 2. And press enter. So I've got the amplitude. So maybe that looks all right. We'll wait and see when we look at it. And so, as you're aware, the period is 2 pi over b, and b is 2 pi over the period. So what I'm going to do now is calculate the value of b using the same principle. Assign a value. I need the Control, divide. Now, with your pi, with the calculator, you can type in 2 pi, but just the students, so we say 2 pi over 2. Now, with those 2 points that you selected, it was only half the period. So what you could do, you can do pi over the difference between the points, but I like doing 2 pi over the actual period. So what I'm going to do on the denominator is actually do the x minimum minus the x maximum. So the x minimum was 1.2 minus 0.65. So we've got the B value. All right, now, so we need the phase shift. So if we go back to the graph and have a look, the phase shift would be from here through to the maximum. So I'm going to assume it's a cosine function. So the phase shift will be just the x maximum. So I'm actually going to say C assigned the value. And what was the x maximum? It was 0.65. And obviously the vertical shift is the y minimum and the y maximum added together, averaged, isn't it? So here we're going to go again. So we're going to say D is assigned the values. And I like using my fraction template. And I go y minimum, which was 0.215. And I'm going to add the y maximum, 0.583. I don't know if you're listening there, Brian. Do you think I've made any errors?
It's looking good to me so far. I was just typing in then that I really like the step-by-step building blocks of this. So it's not just, hey, here's the trigonometric function, or you get the calculator to do all the work magically. We're doing the thinking as we go, which is quite important.
Yes, true. Do the points. Or, as I said, we can always store the values and recall them in, but with the non-CAS, the calculator I'm using here in front of you, like Melissa, the navigator system, and like to really do a step-by-step. So we go
I think it's important too. I think it's important that we remind the students the calculator is a tool, so we're not asking them to do everything with the calculator. They do have to think for themselves, so they do have to understand that background, and then use the regression options to check their work.
Yes. Can you check it another way? That's and it's very reaffirming, isn't it, that the maths that they've learned of the trigonometric functions, or in your case the linear functions, it does tie in.
Yep.
Like
Sorry,
you're right. This is using the line of best fit. One of my favourite activities is Robert Wadlow, world's tallest person. I like using the residual squares. And once I did a line of best fit, movable line, I get the girls to turn on the residual squares, and they say, who's got the smallest residual squares? Oh, okay, you're not close enough, get closer, and that just reinforces that the point has to be closer. But that's another webinar there, mate. We've got a lot of webinars coming out of this tonight, Brian. We could do a lot more on this.
Yeah.
So let's have a look. So we press the menu. I like using this toolbar, or we can press the menu here. So I'm going to go to Analyze Plot a Function. So we said it was a cosine function, so I'm going to go A multiplied by cos. Where'd my function go? Must have clicked out the side. Must have got excited about it. Yeah, there we go. I must have went multiplied by cos. I'm just typing it in. And so with that there, so we've got the brackets. So when you see that there, you can say to yourself, I needed to go B multiplied by x minus the phase shift, and then outside go plus, not F, but D. So when I've actually got that there, you'll see that I've deleted it by mistake, so I can always do it again.
Yeah, the plot function it's not as easy on the stats page as it is on the graphs page.
Yeah, so you can do that there, you can do that one. So if you've actually got that there and you're having troubles with that, or something disappeared, so we've got a bit of time up our sleeve. So what I could do, if you look at the actual, if you've got 0 to 3, you've actually got 0 to, say, 0.6. So let's do that then. So you can do it there. So what I'm going to do is insert a graphs application.
Because the other way to do it would be to build the function on a calculator page, have it defined there, and then call it in the lists and spreadsheets.
You can do that too.
Sorry,
so
the data and stats page. Yeah.
So I'll just do it quickly here. So I'm just going to go menu. I'm actually going to go graph entry. I'm going to go scatter plot. And as we said before, we've got the variable what was at the time, and we had position. So just showing the audience that we still need to change the window, don't we? So you need to be very careful with this window. So if I press enter, it won't actually see the graph, so it's not good. So I need to actually change the window. So obviously same type of thing again. If I actually go into the window settings, I like doing a little bit into the negative. So say -1, tab down to 3, tab down and make the scale 1. And as with the minimum, so maybe negative 0.2. And the highest value, I think it was no higher than 0.7, was it, Brian? Let's go 0.7.
Yeah.
0.2. And there we have it there, don't we? It's the same as before. So it's reinforcing to the students to actually get the equation. So what I can do now is with the entry line, I can go Control G to get the entry line, but it's still in scatter plot mode. So what it can do now is press Menu, Graph Entry, go to Function, and like I was doing before, so A multiplied by cos brackets B. I just like putting the multiplication and just remind the students.
Yep.
X minus C plus the D. How about this time? So, Brian, why is the A, B, C and D bold? And tell the audience.
I think it's because you've already defined it, and we saw you do that on
That's
your
correct, yeah.
page.
So, fingers crossed, ready, Brian?
This is the moment of truth.
Not too bad, not too bad. A little bit out towards the end, so maybe my pendulum wasn't swinging, maybe it's losing some energy, then we can talk about kinetic energy and look at that. It's not too bad, is it? Not too bad at all there. So, that's a little thing about collecting data. It's very easy, plug it in, like students collect their data. So I've actually just gone straight to the computer used as a demonstration where students can use the CBR to the calculator and collect the data there and use it to their calculator, or they can use the cable to their laptop. When they purchase the calculator, they get the software and they can use the software on their computer. With the time that's remaining, another activity that I enjoy using and I've demonstrated in the past is actually the Kite. Now, I first saw this at an international conference and I thought the activity and come home and modified the sheet and activity. So it's called Go Fly a Kite. So it has the areas of, no pun intended, the area of a kite through the Pythagoras theorem, and you could extend it further and to actually use the activity in Year 11 and Year 12 to optimization. So in the kit will be some large black straws. There's a story here. If you ever want straws, you can come to my place because I thought I needed some nice straws without the bendy bits in it, and I went to a catering company near our college, and the minimum size box was 5,000 straws. So my wife wasn't very happy, little box. It's not too big, but I have a lot of straws at school, and we can use straws around the family. I've still got about 4,500 still to go, but start a business up.
I'll remember that next time I see it need some.
Yeah, and then got some string, and what you can do is thread the string through and tie it at the base here, and you've got your kite. And you'll see that the kite, we can work out the maximum area, so students can move it around, they can measure the height and the width, and we'll go and work out the maximum area. So that's the activity. In one of the instructions I had students, but you shouldn't really do it, having trouble getting the string through, suck it through, but no, we can't do that. Workplace health and safety, can't allow students to suck the string through, but have strong surveyor string, bricky string. That's better than the standard twine that you can buy. So that's another thing that I've got there. So if I just close that one down there. And then the activity that you'll see is Go Fly a Kite. And
I was thinking you're probably looking for 4,500 suckers to buy those straws off you, eh?
Oh, we could definitely do that. Oh, you're a funny man. All right, so maximum width of the kite, you see the activity going through here, tie a knot with longer size mid at the base, and we can discuss it, and then you can start collecting data. So what I've done is got a table here that we could say the width is 3, 4, 5, 6, 7, all the way up to 12. Obviously, there's a maximum value somewhere between, say, 8 and 11, quite possibly, so I'm just preempted the table. And you can keep on going through that there. And I'll actually show the Go Fly a Kite formula. And you'll see that within this particular answer I've got here, I've got the string through around the straws. The straws are 15 centimetres in length. There's 6 centimetres here, and what you're doing is pushing the top point down to a certain width, and you can measure the height, and you'll see that using Pythagoras theorem that I can develop an expression for the height of that triangle, the height of that triangle. You'll see it through here. I've got the two heights, and we have an expression for the height of the kite. And as the width is x, that's what we're looking at, which is the independent variable, and the height depends on the actual width. We've got the two variables there, so the height's independent x, so the area of the kite is obviously the two diagonals being multiplied together and divided by 2. We have this little formula here, and that's what I said with the junior school, year 10, you can still do maximums and then go on to optimization. So let the students have a bit of fun differentiating that one in year 11 and year 12. Now they'll enjoy that, so yeah, do that with my 12 maths Bs. So let's
I've got a calculator that can do it.
Yeah, yes, you've got the calculator, yes. So, so what I can do is go fly a kite, as you see there, and we've got a lovely picture, and we've got the data. So what I've got here is actually the width. I'm defining that variable. This is the particular height of that model kite, and we actually have to calculate the area. So obviously I'll call the third column area, and to save time, what I'm going to do is use the formula entry line for that column to work out the area of the kite. Now, this might take a little bit of a while. As you see, there was quite a bit of form. This is where we play the elevator music, Brian, or something like that, or what could we do? So okay, so all jokes aside there, so equal. So what's the area going to be using the formula before? So I'm going to do the control divide. I'm using that little control divide. Obviously, it was the width, wasn't it? So I'm going to hit the variable keypad. It'll be the width. And I need to multiply by those expressions for the height they add together. So I'll do it very quickly. I could have actually done it before. I wanted to show people that it's quite easy to put into 36 minus, there it is again, control divide. Oh, it's getting bigger. So we have the width, and we have it squared, and then we go divide 4. Be very careful here with the students. You go outside the square root. We need to add the second height. And here we go. So we have 225. Subtract. Same thing again. We look at that formula as I showed you before, and you'll see that file, control divide, and we actually have the variable width squared. And then we go divide 4, and don't forget the last little bit which students seem to do, divide by 2. So at the moment, there's the area of our kite, our little model kite. So we can say to students, how was your prediction? So let's have a look. So we could put in a data and statistics page, or we can put in a function, so, a graph application. So we can talk about the area, the domain, etc. So we can work out the particular values. So let's insert in this way a graph application. So we need to actually change it to a scatter plot. And let's have a look. So we're thinking about, we've got area versus, so the y-axis, the dependent depends on the independent. So we've actually got the width, so the variable would be the width. And we actually have the area, and obviously change the window. So it reinforces the student. So it was my viewing window. Where is the viewing window? So if we press enter here, and we'll see that we don't have our window. Oh, it's no good. So we change the window. I like students use the window settings. So negative 10, I like that. So we tab down to say maybe 13, a little bit further than the biggest one. So obviously the biggest width we could do would be 12, the 2 lots of the 6. And let's go to scale being 1. And, or maybe I don't say negative 10, that's a bit crazy, isn't it? So we tab down. Here we go, negative 10. Then go possibly to 100. And scale possibly, we'll say 10. There is our data. So you think, okay, it was a function, okay, so we could actually enter the functioning in. And as you see, it's close to 8 o'clock. So what I could do is enter the function into here. So if I like going Control G. Some people just like pressing the tab keypad, and you go, oh no, here we go, we've got scatter plot again. So we could actually say to ourselves, change it back to a function, and we can put it in again. It shouldn't take too long, Brian, so let's have a look now. Because I'm not using the width, I can use the variables this time, so control divide, and we actually look at the formula. So what was the formula again? So you look at that and you say to yourself, all right, so it's x brackets square root, and we have 36 subtract x squared, well, there it is, and then divide by 4, isn't it? Go outside, plus, I didn't use my fraction template, so I can get away with it. So let's have a look, control square root, 225, subtract, I'll use my fraction template, which I like using. So we've got...
Are you going to have a fancy name for this too, Rod?
Should have a fancy name for it, shouldn't it? We could call it some certain
function.
And don't forget 2. Okay, have I got it right? Let's have a look. Press enter. Oh, what did I do wrong? Let's have a look.
Is it selected?
That's probably what it is.
Yep.
There we go. So we go. Should be fine now. Let's have a look. I think I've got that right. But what I could do, remind myself, I like putting the multiplication in. And there we go. So we have the function there. Obviously, with the senior students, you can do a lot more with the optimization, but a simple thing that I like doing is say, where is the maximum value? So let's go and analyze the graph. We can do the maximum. Now, with the computer, it's quite easy to click and then click. So I could just click into here, click into there, and there's the maximum. So if I didn't like to do that, I'd show the audience, so if I could just go Control Z, and I like to do also to talk to the students about, if I analyse the graph and go maximum, I know it's around, say, maybe 11. So what I might do, I might press 8, enter a value in. And then I might enter a value of 12. And you've got the maximum that way. So it's what you want to do with your students and what they're comfortable with, and look at other things. So I hope everybody enjoyed that tonight. So think about collecting data. So it's very easy to, as Melissa did, put the lab cradle in, you plug it in within half a second, bam, we're ready to collect data, as with the motion detector, with the pendulum, with the ball, and it's amazing what you can do with classes from year level, so year 8 through to year 12, even though we're talking about year 10. So I'd like to everybody, thank you for listening tonight, and we'll talk another time. Thank you very much.
Terrific. Thanks, Rodney, and I think we've got across the webinar, we've got basically 4 terrific investigations there, certainly suited at the Year 10 level. Just a quick recap, we got the 2 linear function investigations from Melissa, the Fahrenheit versus Celsius dual temperature gauge of one temperature, 2 gauges, set in the 2 different units. And then we had our forensic investigation, which links through to that type of numbers activity. One of our participants said that we can still get those activities from the US website. And thank you, Jim, for telling us, reminding us of that. On the Texas Instruments website, the site that my computer is set to will automatically default to Australia, but if you change the site to US and Canada, and in activities, if you then go to all activities and then type into the search box numbers, and as Melissa said, remember it's with a 3 for the E, then you will get that list, and a lot of them that say that they were for the older TI-84 family, of course, can be adjusted for TI-Nspire. So that's another great area of activities. And Rodney then showed us, I think, took us to another level there with the simple harmonic motion of the. And we know he collected the data live because we saw it, and also with the Kite activity. And just a reminder, if anyone's wanting some straws, contact Rodney at Moreton Bay College.
Shouldn't take too much. I should have, Brian.
So thank thank you to both our presenters this evening. I will close the webinar shortly. After that, you will be taken to a page where you're invited to submit some feedback, and please enter all the due praise that our presenters are worthy of there. You will, within the next couple of days, be receiving an email with copies of those files, including the TNS files and the PowerPoints, and you will also receive a PD certificate. If you want to watch a replay of this, go to our YouTube channel or also on the web page where you registered for the webinars. You have the option for registering for an upcoming webinar for live participation or viewing a webinar on demand from the archive. This webinar will be in the archive within the next day or two. And reminder that we do have lots of other support available. So good night to both of our presenters, and thank you very much.
Thanks, Brian. Thanks, everybody.
Thank you, everybody. Have a good night.
And stay tuned for the next one. Cheers.